Okay, let's continue. So functions. For each x value, there exists only one corresponding y value. So y is a function of x. So denoted by y equals to fx, right? So f here means a function of x. Right, just a notation here. So we don't have a specific form of function. So f here means just a general function of x. And let's give an example. So here, this is a graph of a linear function. So when x is 1, y is also 1. And when x is 2, and y is also 2. When x is -1 and y is also -1. So this relationship, we call this y equals to x. So y equals to x means y is a function of x. Well, sorry, yeah, y is a function of x, right? So the fx form here in the example is just y equals to x. And so we draw a line of all the points here, and we can find that it's a straight line. Right, if the relationship between y and x is a straight line, then we say that this is a linear function of x and y. Right, so this is a linear function. So this is called a function because given any kind of x value, there is one and only one y here that is corresponding to the x here, right? But here in this example, we draw a ball right here. And so this is not a function because given an x, for example, x equals to 2, we can find that there are two values of y that is corresponding to the x value. One is 4 and one is 1 here. So this is not an example of a function because there exists more than one value that is corresponding to x. Right, so this is a function and this is not a function. And here are several notes. Note 1, a function is a set of ordered pairs with the property that any x value uniquely determines a y value. So this note is just another kind of definition of function here, right? So just the same thing of the definition here. And the keyword here is uniquely determines. So given an x, there's only one y value that can be determined by x. So this is a definition of a function. So second note, so in this example, this is a linear function because it's a straight line, right? But sometimes we can see this kind of line, and we call this quadratic function. So in a quadratic function, so x still uniquely determines y. So for example, if x is here, and then there's only one y that's here, that determines the x. But we can see that y does not need to uniquely determine x. So for example, given a particular y, we can have two x values that is corresponding to the y value on this line. Right? There are two x values that have the same y. So it doesn't matter, right? Because in the definition, we only require that x uniquely determines y, but y doesn't have to uniquely determine x. So this is still a function, right? And the third note, function is also called mapping. So the y equals to fx can also be written as f and x from x to y, right? So this notation means there's a function called f, or there's a mapping called f, such that it maps x to the y. For given x, you can find a unique y that can be mapped from x, right? So this is just another way of saying the function, right? So these two are equal to each other. These two notations are equal to each other. And the last note, So y equals to fx, and we call x the independent variable, and y the dependent variable, right? Because y is a function of x, and the value of y depends on the value of x. So we call y the dependent variable, and x can change itself, so x is an independent variable here. So pay attention to the different names. Okay, so this is a definition of function, and we have 4 notes. So the last part, we talk about 2 concepts. So this is our last topic here. So domain definition. Domain is the set of all the permissible values that x can take. And range is the set of all the values that y can take. So for example, I have a cost function here. The cost function is C, which is a cost, equals to 100 times plus 10 times Q. So Q is a quantity. So the cost function means for a factory, you can produce a Q quantity of goods. And the more quantity you produce, the higher the cost you will have. So cost and quantity are positively related, and they have a relation like this. And Q and C here is a dependent variable, and Q is an independent variable because the cost is determined by the quantity here. So in this function, we have a condition here saying that the maximum of Q equals to 80. So that means that for this factory, you can produce at most 80 items, right? You can produce at most 80 items every day. So let's find the domain and the range. So domain is really simple because domain is a set of all the permissible values that x can take. So in this example, x is a quantity. Right? We can say that x is an independent variable. And in this example, q is the independent variable. It's an independent variable here. So the domain is just all the permissible values that q can take, which is from 0 to 80, right? Because 80 is the upper bound of the production, right? You can produce at the most 80, and 0 is a lower bound, right? You can produce nothing today, right? But you cannot produce negative quantity, right? So 0 is a lower bound. So I use a set to represent all the Q that the values can take, right? So this is the domain of the function. It has all the values that the independent variable can take, and I use a set to represent that. And from the function, we can see that first is a linear function, and if I draw a line in the Cartesian plane, and it looks like this, it's upward sloping, and when Q increases, the cost also increases, right? So for this function, we want to find the range of the function, which is the range of the C. And we need to find the minimum and the maximum of the values that C can take. But we know that when Q increases, C also increases, right? So the minimum value of the C should be when Q equals to 0, or when Q equals to the minimum. And the maximum value of C should be when Q equals to the maximum, right? Because they're positively related. So when Q equals to 0, the C is 100, and when Q equals to 80, C equals to 900, right? By simple calculation. So the range should be between 100 and 900, which is the set of all the values that y, or the dependent variable, can take. And in this example, the dependent variable is a cost. So we need to find the minimum and the maximum values that the cost can take, which is 100 the minimum and 900 the maximum. And I also use a set to represent the range of the C, right? So this is the end of the chapter 2, and hopefully just a review of everything you have learned before. Okay.